State whether the following statement is true or false. Justify your answer. Point A, B and C are collinears such that AB is 2 times of AC by 9. First thing is, I would like you guys to understand the word collinear. If not, there's no point, right? So what is this collinear? Collinear, I made a point over here. So we have the collinear, yeah. 3 or more points are collinear if they are on the same straight line. Okay, so that's about collinear. Actually, I'll show the answer itself. The first part though I can answer. Such that AB is equal to 2 times of AC by 9, that I can't answer, but I can give you guys the idea about collinear. Okay, so let me simulate this and show it to you guys. So I've written down the points -6 and 10. The second point is -4 and 6. Third point is 3 and -8. Okay, so these are your points. You can pause and have a look. This is point A. I think this is -4 and 6. Yeah, this is point B and this is point C. So what does collinear mean? All these 3 points are on the same straight line. It can be more than 3 points. It just need not be 3. It can be more than 3. But yes, they're collinear in the same straight line. Okay, I hope you guys understood what does a collinear mean. Now on to talking about the other aspect. AB is equal to 2 times of AC by 9. So all of this can be answered with the help of your distance formula. So if you just want to talk about if things are collinear, there are many ways. You can use distance formula, you can use section formula, or you can use area of triangle. Actually here I've used area of triangle concept. So you can see the area of triangle is 0 unit square. You'll end up with this answer. If you end up with such an answer using area of triangle concept, means what? The lines are collinear. So you can see if this was supposed to be a triangle, clearly the area will be 0. It does not have any area because it's a line. It's one dimension. Right guys? So the point is we can prove the idea of collinearity in 3 different ways. But because we have this aspect also, I won't be able to use that. Okay, so let me move on to using distance formula. Right, this is the only one which I can use to prove all of this in a simple and straight manner. So using distance formula. So the basic idea is what? I'll find the distance between AB, BC and AC. So if the things add up to the same value and so on and so forth, you guys have done this. So then the answer is that yes, they are collinear. So let me do it and show it to you guys. What do we have? X2 minus X1 the whole square plus Y2 minus Y1 the whole square to the power of half. So we have AB, which is equal to X2 is -4 minus of -6 the whole square plus 6 minus 10 the whole square to the power of half. So this is I'll do a step which is not exactly required, but only for your understanding, that's it. Right, minus of minus is plus square plus -4 square to the power of half. So we have 6 minus 4, that's 2 square. So what I'm trying to tell you here is you can skip this step and you guys could have directly gone with writing this as 2 square plus 4 square. And we have this to be 4 plus 16, that is 20, square root of 20. And square root of 20 can be written as 4 into 5, right? Square root of 4 into square root of 5. This is with the help of this particular formula. AB whole to the power of n is a to the power of n into b to the power of n. Okay, and so we have 2 root of 5 unit. Then we have BC, which is equal to b is -4 minus 3 the whole square plus 6 minus of -8 the whole square to the power of half. And then we have 49 Or let me show this actually. 7 square plus, this is plus 8 plus 6. 8 plus 6 is 14. 14 square. Either I can expand it, so on and so forth, and do this, or I can do one more thing. How can I reduce the calculation? See, 7 square plus 14 square, what is common? 7 square is common. Okay, let me explain it over here. I don't want to waste space over there. Plus 14 square is nothing but 7 square plus 14 can be written as 7 into 2, is it not? The whole square. This in turn can be written as 7 square into 2 square, right? 7 square plus 7 square into 2 square, what is common? Yes, we have 7 square common. What is left out? 1 plus 2 square. Close the bracket, close the square brackets, and we have the following. And then we have square root of 7 square into, this is 5, so this is basically root of 5. And then we have the answer, square and square root. So this is 7 root 5 unit. Okay, and then we have to figure out AC value. So AC would be equal to what, guys? A is minus 6 and 10. Oh yeah, I have the values. So, and B, C is 3 and minus 8. So 3 square plus, this is 10 minus of minus 8. See, 18 square is something that I won't usually remember. Okay, so I end up doing a lot of calculation. Instead of that, alternatively, you can use distributive property. That's all I'm doing. I'm using your junior syllabus, so make use of all of that. So this is 9 square plus, this is 18 square. Again, here instead of doing 9 square, that is 81, and 18 square, which I am not very, 64, 324, yeah. By chance I remembered. What if I didn't remember? Alternatively, and even though I know this, I won't do it, because then 81 plus 324 and you'll get some number, and square root of that is not something that I might know. Then I have to factorize and all of that. It's a big headache. It's lengthy basically. So instead of that, I'll write it as 9 square, taking out 9 common, basically 1 plus 2 square. Does this make sense? Close the bracket to the power of half and say this is square root of 9 square into square root of 5. So this is 9 root of 5 unit. And we are almost there. We have AB plus BC, right? If I find this length to be equal to this length, we are done. So AB, guys, is how much? 2 root 5 and 7 root 5. See, it's not that AB plus BC has to be equal to AC. It could have been AC plus something else also. B need not be in the middle. So you have to be careful about understanding the concept and applying it. It should not be that B has to be in the middle. It can be anyhow. So don't get fixed onto that B has to be in the middle part, So it could have been any other way. This is 2 root of 5 plus 7 root of 5, which is 9 root of 5 unit. And this in turn is equal to AC. So basically we just proved that these are collinear. So it is pretty long, that I agree, but because of the other aspect, AB being equal to 2 times of AC by 9, I had to do this. If not, we could have gone with area, or if not, section formula directly. Okay, so area formula, you guys have not, some of you might have not learned this. Where is it? Yeah, it's over here. It's a simple formula, but anyways. With that, if we substituting and solving this, if we get 0, means the points are collinear. Okay, guys. So back to the screen. What do we have? Yeah, we have to prove this aspect as well. So I'll directly take the expression, substitute it, and we'll see. So this is what we have to check. So is AB, yeah, AB is 2 root of 5. AC is 9 root of 5. not 2, 9. And so we have 9 and 9 getting cancelled. So clearly LHS is equal to RHS. It's a true statement. So since we have the true statement, means what? The given expression is true. So to conclude, the points A, B and C are collinear and AB is 2 by 9 times of AC. Right guys, that's it. So it's lengthy, but yeah, the main thing here is this aspect calculation. So I'll give the star to this aspect. And over here also we did it 2 times. So please make use of this, right? And your basics and the formulas and all that is over here, and the basics has been taught in your basic maths, and first chapter also we kind of make use of the idea of exponents, right? So learn from all of that.